Good afternoon, everyone, and welcome back. I'm Steve.
And I'm Scott.
And together we're Backyard Musings broadcasting on People's Republic of California.
Yep, specifically Apple Valley, and we're talking science and technology. Definitely science today.
We've had some space, astronomy type segments. There's a lot of stuff happening.
Yeah, Final Frontier, right?
Yeah, it's pretty cool. All right, what you're looking at right now is the path of a comet. And like the title of the segment says, Interstellar, so it's not from our solar system. And it's coming in between Mars and Earth. That's pretty close for an interstellar, no coinkydink, you know what I'm saying? That's crazy.
Yeah, but I think we're gonna be good. So don't get out and
don't
freak out.
Right, don't freak out. Okay.
Yeah, I think we'll be okay.
MGO Blue astronomers are helping study a fast-moving, ancient, and massive comet that formed beyond our galaxy. A group of astronomers from around the world, including a doctoral student from the University of Michigan, were the first to report the discovery of the third confirmed interstellar object to enter our solar system. The announcement was made on July 3rd. Following the discovery, Aster Taylor from the University of Michigan's Department of Astronomy and Darryl Seligman of Michigan State University, they're co-authoring? They're working together?
Guess so.
This is crazy. That's a huge rivalry.
U of M and MSU.
That's a huge rivalry.
Yeah.
Okay. Where was that? Co-authored a new study that begins to explore the properties of this newly identified object named 3I Atlas.
Okay.
3I Atlas. This research was published on July 3rd, as I said, 2025, in the journal arXiv. I don't know, arXiv? I don't know how to pronounce that. arXiv. Would you like to know more?
It's almost like a Romeo and Juliet story, right? MSU, U of M.
Yeah, maybe something can,
Man, it just, yeah.
It's really even worse than the Ohio State and University of Michigan rivalry.
Defying the law of gravity there, right? It could be. Okay. Unlike objects that originate within our solar system, interstellar objects form elsewhere in the galaxy and pass through without becoming gravitationally bound to the sun. The arrival of 3I Atlas, along with the two previous interstellar visitors, has provided scientists with rare and valuable chances to investigate distant galactic environments. Public enthusiasm plays a vital role in sustaining support for funding and the development of advanced technologies that make future discoveries possible. One example is the Vera C. Rubin Observatory, which began operations this summer with backing from the U.S. National Science Foundation and the U.S. Department of Energy. While it was not responsible for discovering 3I Atlas, Taylor noted that the observatory is expected to identify one or two interstellar objects each year.
Interesting.
So they're expecting more.
Yeah, if you can't go to the mountain, you bring the mountain to Muhammad, right?
Okay.
All right. NASA's Asteroid Terrestrial Impact Last Alert System, ATLAS. Asteroid Terrestrial Impact Last Alert System. That makes sense. Why do they come up with these catchy phrases?
I don't know.
Enabled,
paid the big bucks.
Probably AI. Enabled the discovery of 3I Atlas. The system, and this is the third, so that makes sense. 3I Interstellar. Okay. The system includes 4 telescopes, 2 located in Hawaii, 1 in Chile, and 1 in South Africa, that automatically scan the entire sky multiple times each night to detect moving objects. Interesting.
Yeah. As its name suggests, Atlas is designed to detect potential threats to Earth, but in this case, the object poses no danger. It will not collide with our planet and will remain at a distance greater than between Earth and the Sun. So it's pretty wide.
Yeah. Taylor, we'll see it.
Yeah. Yep.
Taylor noted that 3I Atlas is most likely a comet. It is surrounded by a hazy envelope of gas and dust that forms around the solid core. As the object approaches the sun, this coma is expected to change, offering valuable insights into the comet's overall makeup.
Over the coming months, space telescopes like Hubble and the JWST will be able to zoom in on 3I Atlas to probe these and other questions about its size, spin, and how it reacts to being heated. The researchers were able to work out some important characteristics from their initial observations Specifically, 3I Atlas is faster and larger and older than its predecessors. 1I OU O
Oumuamua.
Oumuamua. Okay, this is Polynesian.
Oumuamua.
Oumuamua. And 2I Borisov.
That sounds Russian right there.
Yeah.
We're gonna take the slide off.
I
so
wonder
you
if
can
it's
see our
because
faces.
maybe that's where they'd first discovered these. So
Yeah,
they gave it.
well,
Oumuamua was
Hawaii
discovered in
it, so
Hawaii.
they- yeah.
Okay.
Borisov was probably discovered in Leningrad or something.
Yeah,
I don't know,
something.
Stalingrad.
Yeah.
All right. 3I Atlas has a hyperbolic velocity of just under 60 kilometers per second, roughly 130,000 miles per hour, compared to 26 for Oumuamua and 32 for Borisov. Ooh, that's a fast one. The diameter of 3I Atlas is currently estimated to be as much as 10 kilometers or 6 miles, which would be 100 times that of Oumuamua and 10 times that of Borisov. But Taylor is confident those numbers will shrink as astronomers get better observations of 3I Atlas. Such a large size would imply galaxies are way more efficient at making these kinds of objects than is physically possible.
Finally, Oumuamua and Borisov have ages measured in millions of years, while 3I Atlas appears to be between 3 billion and 11 billion years old.
How can they tell
How do
that?
they know that? Yeah,
I don't know. I think
is.
I know.
Well, we're going to go with it, but yeah, I don't know how. Let us know if you think you know how they come up with
I
these
don't
ages.
know.
This is another number that Taylor suspects will ultimately turn out to be toward the smaller end of the range. Okay, so 11 to 3 billion. But it will be interesting to regardless because it can provide more clues about how our galaxy was forming stars, planets, and other objects earlier in its history.
Isn't that interesting how our galaxy was forming? We know who formed it.
We know who formed all of these, right?
Yeah.
Yeah.
All right. Taylor was recruited for the project while traveling to help confirm 3I Atlas was an interstellar object and make early characterizations. So he was a hired gun. Huh.
Okay.
And there was a time crunch. If the Atlas team had noticed 3I, odds were another astronomers had too, and the team wanted to confirm its suspicions and get the news out first.
Okay.
Non-disclosure agreements.
Yeah. Larry Deno, a member of the Atlas team, reviewed and submitted the discovery observations from the European Southern Observatory's very large telescope. We've talked about that because we made comments. Is there a large telescope? And now there's a very large telescope?
Yeah.
In Chile, shortly after it was observed. So, okay.
John Tonry, another member of Atlas and professor of the University of Hawaii, was instrumental in the design and construction of Atlas, the survey that discovered 3I.
Once 3I Atlas was confirmed, Seligman and Karen Meach, faculty chair for the Institute for Astronomy at the University of Hawaii, both managed the communications flow and worked on getting the data pulled together for submitting the paper. Okay. Give credit where credit is due.
They worked hard for that.
Yeah.
There was a race.
And I guess Hawaii, you don't think about it, but I guess Hawaii would be a good spot for an observatory, right? Or a telescope.
Way up there because it's the tallest mountain on the world, measured from base to top.
Right, and they get storms in there, but I don't think storms really affect that, right? Affect telescopic
Not that
vision.
They're above the cloud
storms.
cover and stuff. Yeah.
So it's a good place. Yeah, and like I say, you don't think about it.
The Hilo's got a policy of like the low sodium lights, so that they're not bright, down in the city. It's just specifically for the astronomy.
Huh. Interesting. Yeah. Okay. Well, there you have it, folks.
All right. Thanks for joining us. We'll catch you tomorrow.
Watch out for that comet. Take care. Thank you.
And the earthquakes.